spectrum. What are the different bands? That means what are the different frequency range comes under different bands. What are its applications, advantage, and applications? So the couple covering up to these 3 points: introduction, advantage, and applications. Okay. So to start with, this is the electromagnetic spectrum, which the study of microwave frequency range is specified in this. With this application, we will be discussing its application. Okay. So before that, so I hope everyone is able to see the screen. Okay. So any problems or the explanation will be given in the board here. So I'll be using the paint or this board for writing purpose. So if you are asked anything, you just acknowledge by switching on your mic. So we will start with okay. So coming back to this is the electromagnetic spectrum, defining a different frequency range. Okay, starting from zero frequency, that is 0 hertz, to 3 hertz, 3 kilohertz, 30 kilohertz, and gigahertz, so till here. Okay, but what we'll be focusing much here is this range. It is from 1 gigahertz to 300 gigahertz. Okay, so starting initial, there is a very low frequency where you have a time period of Earth's rotation or subway bridges, or in terms of 50 hertz or 60 hertz, the AC power supply of India and the various other countries, and a certain frequency range in terms of kilohertz where CRT monitors are used, AV, TV, audio, video, which is around 800 megahertz up till. Okay, so your microwave starts from 800 megahertz. It is zero point 0.8 or approximately 1 gigahertz, and it will range up to 300 gigahertz microwave frequency range. So which are all these are the applications which comes under those, um, this base station, cell phone, cell tower, microwave ovens, Wi-Fi, satellite, cordless phones, wireless, smart meter. So these are the major applications which comes under this microwave frequency in between, and say in between these range 1 gigahertz to 300 gigahertz. So above 300 gigahertz it is infrared and visible light to particular frequency range, and then UV, X-ray, gamma rays, and so on. Okay. So we will be not discussing much about these ends, extreme frequencies, lower and higher, but preferably we will be discussing about this 1 gigahertz to 300 gigahertz. Okay, how this frequency range is distributed and named it across the different band regions and what are its application. Okay, so any doubt up till here? Just for the introduction. So if no doubts, we will be moving to the next. Right, we will be starting with the frequency range what I have mentioned here, starting from 1 gigahertz to that is zero point 0.8 giga or 800 megahertz or approximately 1 giga to make it round off to 300 gigahertz. Okay, so we have from 1 to 2 gigahertz, we define it as a L band specified by the IEEE standards, and some of the applications which comes under these category are GSM, CDMA for the audio applications and video to certain extent. Okay, so this is from 1 to 2 gigahertz. So from 2 to 4, 2 to 4 gigahertz, what happens? It is S band. You call it as S band, and then the frequency which the applications which comes under this S band or weather forecasting, weather forecasting, surface ship radar, microwave ovens, microwave ovens, Bluetooth, Zigbee, which are all some of the applications comes under these categories. Okay, so these are some of the applications which comes under 2 to 4 gigahertz, which is defined as the S band. Okay, and next 4 4 to 8 gigahertz. 4 to 8 gigahertz, you define it as a C band. Okay, and the applications which comes under this category are satellite communication, some of the radar applications, some of the applications which comes under the C band, where the frequency range is about 4 to 8 gigahertz. Okay, so next, from 8 to 12 gigahertz, you have a band named as X band. You have an X band. Again, here you have the same satellite communication, but preferably for the education purpose, where all your MOOC course, NPTEL, SWAYAM courses will be uploaded, and along with this, some of the microwave test benches which you use in the uh, laboratories, communication laboratories. Okay, so these are some of the applications which comes under 8 to 12 gigahertz, which is defined as an X band. Fine. And the next is 12 to 18 gigahertz. 12 to 18 gigahertz, you define it as a co-band, okay, co-band, and the applications are satellite TV communication, which is VSAT or something like that. Okay, where you're going to transmit and receive the audio and video signals broadcast in terms of broadcast application. Okay, so this comes under 12 to 18 gigahertz, which is defined as a co-band. So the next is 18 to 27 gigahertz. From 18 to 27 gigahertz, you defined it as K band. Okay? We defined it as K band, and the applications which comes under this are uh, armature satellite, communication, that is preferably for astronomy applications. Okay, astronomy applications in the things about to understand, it is nothing but the study of intensity. Based on the intensity of stars, you decide the size, distance, mass of that particular stars. Okay, so that study comes under this frequency range 18 to 27 gigahertz, which falls under a K band range. Okay, and next from 27 to 40 gigahertz. 27 to 40 gigahertz, you define it as a Ka band. Okay, you define it as a Ka band, and the applications are nothing but again under satellite communication. Satellite communication, you have high resolutions, and low range radars. That is particularly 4 to 6 kilometer of range. Okay, where you can determine the objects, military airplane, which will be accurately determined within this frequency area, I mean this distance range, 4 to 6 kilometers. Okay, so this is the applications. These are some of the applications of this frequency range, 27 gigahertz to 40 gigahertz, which is defined using Ka band. Okay, so the next is 40 to 40 to 75 gigahertz. So from 40 to 75 gigahertz, you define it as a V band. You define it as a V band, and the applications are uh, high capacity terrestrial terrestrial millimeter range communication. Okay, so this you should be familiar that it is in the millimeter range communication. Okay, where you will be having a very large bandwidth. Preferably you will be having a large bandwidth and high speed military application, military applications. And next from 75 to 110 gigahertz. So 75 to 110 gigahertz, you define it as a W band. Okay, and again the applications which comes under this category are the millimeter wave radar, which is used for research application, like some of the agencies like ISRO, DRDO, NASA used to work at this frequency range. Okay, so which is at a very high frequency, 75 gigahertz to 110 gigahertz, which comes under a W band. Okay, and the last one is 110 gigahertz to 300 gigahertz. Okay, so the band itself is defined as millimeter band. Okay, and the applications are satellite communication, um, millimeter wave communication, which includes all the above parts which I told. Okay, that means short, long distance, large bandwidth, high accuracy. Okay, so especially for the military applications, this frequency range are especially used for the military application. Right. So just to summarize, this is nothing but the different frequency range which is uh, categorized across different bands which comes under this microwave. Okay, so you see here at the microwave, which includes all these things which I told, comes under 1 gigahertz to 300 gigahertz, if you could see here. Okay, and you see this is zero frequency, 3 hertz, 3 kilohertz, 30 kilohertz, 3 gigahertz. The frequency keeps on increasing, and you see the wavelength or the time period keeps on decreasing over here. Okay, the frequency is so high here such that it becomes ionizing. Ionizing means the the wave used to break or ionize the molecules or the atoms through which these waves are subjected to. It might be body or any other material so far. Okay, so that is what I was actually mentioning with an example of giving a circuit which is operated at normal frequency and what happens at the high frequency. Okay, so here with respect to the circuits, what happens? Here, when you are analyzing it for a simple RC circuit, um, certain voltage or current or high frequency or low frequency are the only parameter which you are going to analyze. Okay, so for the same circuit, if you keep on increasing this frequency, okay, what I mean to tell is the same. If RC circuit, if I give the input signal as some gigahertz range, so what happens? It is not only the voltage or the current parameter which comes into the picture, but also the time and the space. Okay, the now it is not V or I, it is V of t and I of t which comes into the picture for the same circuit. I'm telling you. Understood? So that is how the thing changes from low frequency to high frequency, which I was mentioning. And just to summarize the same, so from 1 gigahertz to 300 gigahertz, so 1 to 2 gigahertz, it is L band. So these are the band which is defined by the IEEE standard, preferably for the communication purpose, communication application. Okay. So 1 to 2 gigahertz, it is L band, which is used for GSM, CDMA. 2 to 4 gigahertz, it is S band, weather forecasting, surface shaped radar, microwave ovens, that is 2.4 gigahertz, which it works with Bluetooth, also same range, Zigbee. These are some of the communication tools which you can use during your project's time also. We will come to know about this. Okay, so 4 to 8 gigahertz, it is C band, which is used for satellite communication, radar application. Okay, and 8 to 12, it is X band, which is used for the satellite communication, uh, education purpose, or some of the microwave test bench which you use to work in your laboratory. Okay, and 12 to 18 gigahertz, you call it as KU band or Q band, where the same satellite TV, VSAT, audio, video communication used to happen. So 18 to 27, it is K band, armature satellite communication or the astronomy. So based upon, it is basically the study of stars based on the intensity, its size, mass, distance, all those things are discovered. 27 to 40, it is Ka or Ka band, which is used for high resolution and for low range only. Okay, low range radars, which means specifically is 4 to 6 kilometers. And then 40 to 75 gigahertz, you define it as a V band, which is for which has a very large bandwidth and high speed military application. It is used for high capacity terrestrial millimeter range communication purpose. Okay. So 75 to 110, it is W band, millimeter wave radar, where some of the research agencies like ISRO, DRDO, NASA used to work at this frequency range. So 110 to 300 giga, it is millimeter band. Okay. So millimeter wave communication, preferably the military applications are the one you are going to utilize. Okay. So this is about the frequency range of microwave and its study. So any doubt up till here? So introduction about the frequency range of microwave, its standards with respect to certain applications. Okay, so now we will move on to the next topic, which I'll take it as advantages of microwave. So tell me, what are the advantages you can come across in this frequency range? One, first and foremost, which you can see is bandwidth. It has a very large bandwidth, which you can see here. Okay, very large bandwidth. It has a very large availability of bandwidth, and the second is directivity. Okay, so the directivity property is very good here. Directivity means you can use it for a very high frequency. Since it is at a high frequency, you can use it for a long distance communication purpose. It means directivity means is for particularly this application. Okay, and the third is the compatibility or portability. What does it mean is higher the frequency, the lower the size of the circuits will be. Okay, that is the point to note that. Okay, so what I mean is higher the frequency, lower will be the size of the circuits. And obviously long distance communication purpose, and then fading is less. Fading is less. Fading means it is nothing but the wave is getting losing its strength. Okay, so as I was telling, satellite communication, radar, some of the major application which you can think of. Uh, at the Earth atmosphere, it is going to travel at a different layers across different layers. So when it is moving from one layer to another layer, there might be reflection, refraction, or certain phenomena, or preferably scattering of those waves. Okay. So fading is less means that is the same. The scattering phenomenon will be less at these frequency ranges because it is very high frequency. Hmm. And what else? Beam width. Beam width is small, very narrow. Beam width is very narrow. Okay, so hence used for long distance communication. Long distance communication. So beam width narrow means how can you justify this? So B, the expression for a parabolic reflector antenna, for a type of parabolic reflector antenna, what happens? So the beam width is defined as ratio of 140 divided by divided by diameter of that antenna plate, diameter of that plate divided by lambda. Now there is a symbol of lambda. I'll just write it as lambda. Where B is beam width, D is diameter of antenna plate, and L I write as lambda. So 140 divided by D by L, okay, or 140 into L by D, this expression. Okay. So what I mean to say here, or you can understand from this theory, just a minute. See, if you have a frequency of some 300 megahertz, if I have a frequency of 300 megahertz, lambda of some 1 meter, wavelength of 1 meter. Okay, so you are designing it for a beam width of some 100. Okay, so beam width of the which is 100. So calculate what will be the value of p here. Calculate can tell me what will be the value of p. 1.4 meter. Sorry, Karthikeyan. Okay, so you see the diameter of the plate is actually 1.4 meter. It is. See, again, I will change the specification, but the beam width I will keep it same. Okay, so now think it for the frequency of some 30 gigahertz. 30 gigahertz. Okay, that means your the lambda value is around 0.01 meter. Frequency large means obviously your wavelength, that is lambda, will be less, right? Zero point zero 0.01 for the same beam width. B is equal to 100. Beam width is 100 degree. So what is the value of D here? What is the value of D here? 1.4 centimeter, correct? Okay, so it is 0.014 meter. 1.4 centimeter. Correct, right, Karthik? So what you draw from this, Karthik? Can you tell me? As we increase the frequency at a fixed wavelength, okay, the size of the antenna becomes smaller. That means the diameter is decreased by almost 100 times. Okay, so you see the size of the antenna is reduced 100 times if you increase the frequency by 100 times, obviously the same proportion. Okay, so this is what the things will get changed from low frequency to high frequency. Okay, so that is what compatibility sizes will get changed. Long distance communication do it very fade, uh, fading is less, right? So all these things are because of this microwave frequency range. Okay, so we haven't come across any particular problem definition yet, but this is just an example for you to tell how the things will get changes from low frequency to high frequency, that is particularly at the microwave frequency range, right? So these are some of the advantages, and next coming to the applications. Yes. Any doubt in this? Advantage, advantages, bandwidth, directivity, compatibility, long distance communication, fading, being with this nano. Yes, any doubts? Okay, I'll just briefly mention about some of the other applications we have already discussed it, but broadly across particularly what happens at the civil applications, what happens at the military applications, and medical infrared. Okay. So what are the things that changes at the civil applications? Like preferably the wireless communication, which is used for like TV, telemetry, communication, right? You can also include some of the commercial also, commercial applications like microwave oven, microwave oven, um, which are some of the frequency range used for textile, food to determine its color or ambient, that is its whether it is ripe or not, um, and some of the other applications if you come across. Okay, and so in the military applications, what are the things that you come across in the military application? To detect aircraft or unknown objects, unknown objects, uh, any other planes or unknown objects in the enemy territory, like preferably using radar. You can also use the depth of the sea, um, ECM, that is electronic countermeasure or electronic counter measure. Right? So along with this, any other missile guidance, missile guidance and control. So these are some of the applications of military. And in the medical applications, which you are familiar, like detection of cancer or tumor, right? Or some of the diagnostic or therapy, right? So just to summarize the same or tell it in the brief, these are some of the applications which you can use in a broader way, particularly uh, with respect to those what we have discussed at the beginning. Satellite communication, domestic purpose, GSM, millimeter range, radar, low frequency, low distance, high speed, military applications, and so on. Okay, so the same things which you can categorize preferably in a three broad way: the civil or domestic applications, military applications, or medical applications. Right? So these are some of the applications what we can brief about. The advantages also we have discussed it. So the radiation hazards, I'll just take this topic it in the next class. Okay? So anything else? Any doubts so far? ಕೆಳಗಿನ ಮುಂಚಿನ ಟೈಪ್ ಮಾಡ್ಬಿಟ್ರಿ ನೋಟ್ ಅಂತ. Okay then, we'll break for today. Just a minute, I'll just 54, 53 students. Just record 52. It's enough.